Hello and welcome back to the third part of the Satisfactory tutorial. In this part, it's going to be a bit of a follow-up to the conveyor belts we did in the last part. We're going to be setting up a system so that they can be connected between each other and connect to buildings in the future. So that's what we're going to be working on today. We're going to start off by simply importing a little asset. You don't have to use this, but it will make it easier, let's say, to see what's going on. So we're going to be importing, let me just get it right here, an arrow. And this arrow is just going to be to indicate the directions of which stuff is flowing. Not for the conveyor belts, but more for the different inputs and outputs in the machinery later. So let's close that. And we can get started. So we're going to start off by making a new blueprint. It doesn't have to be based on the build, it's going to be a completely new one. It's going to go and be called A_attach_point. So A_attach_point is pretty much what we will be calling at the end of each conveyor, and it's going to be the thing we're going to attach to each building, and we'll just be setting up so that once we hit it with our line trace, we can actually move it to there. So before we move on, actually, I need to remember to do this. Go into Edit, Project Settings, and we're going to need 2 extra collision channels, so we're going to be looking for trace channels here. We want one we'll call Deconstruct, which we'll be specifically using for when we want to destroy an object, so that way we can ignore these trigger volumes then. Then we want to call another one we'll call just General. There we go. Leave them both on block, and we can close this. So the attach point is going to have 2 components. The first one is going to be a box, which we're going to add box collision, and the next one is a static mesh. Now the static mesh is there, and if I remember correctly, okay, so for the attach point, we're going to have, yes, a static mesh, a box, and the static mesh, we want to set it to 50 and 40 on the Z, because we want it to be slightly in front of where the actual cube is, or where the box will be. We can call this arrow, and that's exactly what it's going to be. We're going to get our arrow assets, double R, not 1, and there we go. So by default, we're going to set up some functions that we can make it visible, invisible, depending on the situation we want. So let's get into it. So actually, sorry, we also want to just disable collision here, because the arrow shouldn't be detecting anything. It's just simply visual and nothing else. For the box, we need to also change the collisions very quickly. For the size, we're going to be doing it at runtime and in the construct script. So we go down to collision right here, and we're going to set it to custom, obviously, because we need something special for it. We want to make sure it blocks visibility and blocks camera, but we want it to ignore deconstruct and ignore general. So the reason we do this is so that later on, when we want to destroy an object, we aren't getting blocked by the box. But at the same time, we'll be using general for collision detection, so that it doesn't cause any issues detecting this box as something to block the IsBuildable. The rest we can leave as is, it's not a problem. Okay, so next up are the different variables. So for the variables, we're going to start off with one called show arrow, which is very simply just going to display the arrow. We'll leave it true to start by default. We want it to be exposed on spawn, and we'll put it in a category we'll call setup. We can then duplicate it, and this one will be vector size, which will be obviously a vector. And then we're going to add another one we'll call location offset. Now the reason we're doing a location offset and not simply just going to be dragging it manually is because we specifically want the scene route to be at the same spot all the time, because otherwise we would have conveyors attaching to an unknown location. Next, well actually before we do the next one, we need to actually create our enum for it, so let's do that. So in our blueprints, we're going to go and look for the blueprint category and an enumeration. So call it E direction and open it up. We're going to need 3 here. The first one is non-specified, the second one is input, and the third one is output. So these are pretty much the directions that a attach point or a conveyor can have at a given point, beginning or end. So we can add our new variable, which we'll call direction. And it's going to be of type E_direction. Make sure you choose our one. And by default, we're going to leave it as non-specified. Two more variables left. One we'll call parent build. Now this one doesn't need to be exposed, so we can leave that off. It's going to be of type aBuild, or aBuilds in our case. And we're going to duplicate it. And the second one is called connected builds. This is how we're going to tell between the different conveyors and the different attach points what they're connected to. So with these two, we'll just put them in a separate category as well. We'll call it builds. There, we can attach it. There we go. So that does it for our variables. Next, we have three functions. First one we'll call update size. And update size is going to have these two here, and we're actually going to set them. The reason we're going to do it this way is so that in the construct script, we can just call it immediately, or we'll set it up now. We'll call it like this, so that even in the construct script, we can just change our values here in, for instance, another blueprint, and it will set it up correctly. But at the same time, if we need to modify it later, we can do it at runtime with custom values. So for the rest, pretty simply, we're going to add a sequence. Then we're going to check whether we want to display our arrow. So to know if we want to display our arrow, it's very simple. We want to check if this is double equal to non-specified, meaning no direction, or if show arrow is not true. If these two conditions are met, then we are going to destroy the component, or yeah, we're going to destroy the component. So we will validate it. Actually, no, sorry, not destroy. We want to simply call it set hidden. So let me just get that and say set hidden in game. And we'll say true. And obviously on false, we'll do the opposite. And we'll say visible. Next, what we want to do is we want to create a dynamic material. So create dynamic material instance, plug it in here, and we'll be looking for our MI hologram. So it's like that, and we'll create a local material here, even though actually we can also just do it like this. We'll just add a reroute here, and we're going to look to set vector parameter value, and this is going to be the color. So for the color, what we want to do is we're going to get a select node here, but we need a direction for that. So we'll get select here and plug that in here. So for input, we'll say green. So we'll just drag the green slide all the way. For output, red. And we're done. For non-specified, leave it black because it's not even going to call it anyway. Next, we want to call our arrow and say set material. Right here. And just grab our reference there. Just align those up. And to finish, one last thing. If the arrow is visible, we want to change its direction based on the actual direction. So set relative direction, rotation, not direction. And we'll once again use another select node here. So we'll copy this one and we will, can we reset this? No, so we'll just get a new one then. We'll say select, plug it into new rotation, and we're going to set it to 180 on input, and that's all. So the last thing to do for this function is we need to actually change our location and offset and size, sorry. So for that, we get our box here. We say set relative location, and we attach that here. We can also say set relative, no, not set relative, set extent. So this will be the size of the box. And for the size, we simply just get our size. But for the actual location, we'll do it a bit differently. We want to get the size, we want to get the offset. We want to multiply the size by 1, and only on the X. And then we want to add the offsets. Go, and this goes into our new location. So with that, currently right now, it will make our box invisible because our default values are 0. So we're actually only going to change the vector size. We'll leave the offset as 0. We want it to be 15, 62, and 35. And this is the actual size that's going to, let's say, encompass a support beam. So that way, if we hit a support beam that's already connected, it won't take it into account. So that almost does it. We need 2 more functions left. One is can conveyor connect, which is what we were just discussing. So what we need to check for the conveyor is very simple. If we want it to connect, we need to know what direction we're trying to connect to this actual attach point. So we want to get the in direction, let's call it. And so that's going to be e_direction. And what we want to check is if it is double equal to non-specified, that means it can attach and it will be converted. So it's not a problem. But we also need to check if that's not the case, if it is different from this direction, because if it's an input, it needs to go into an output. So they need to be different. So we're going to call not equal. Make sure you choose the enum one, otherwise it won't work. And we want in direction. So if either of these are true, then that means we can attach it based on the direction. But we also need to check that we don't already have a connected build, because if we do have a connected build, then we can't actually attach anything because it's already done. It's already, the space, let's say, is already occupied. So we need to add a return value. And the return value is simply going to be, well, actually, let's just do, we'll just connect it here, okay? But we want to make sure it's a not boolean, because we want to check if it is not, then we can. So we can copy this below, sorry, no. Below it's automatically false because the conditions here haven't been met. So we just don't accept it anyway. So next is the last function, and it is simply going to be, well, setting up our connected build. So we want to call link connected builds. So what this will do is it will have, once again, a return boolean, because we need to check if it succeeds. So return value, a boolean. And what we want as an input is we need to actually know what attach point is coming in. So we'll get in, or actually other works better this time, attach point. So let's just get a reference to that, a attach point. And we'll call it here, get other attach point, and we'll say get parent build here. The reason we want parent is because we can then link the 2 parents together. So we need to check if it's valid, because if it's not valid, we can't do any of this. So obviously if it's not valid, we return false. So if it is valid, we want to get our connected build, and we want to set the parent build of the other one to this connected build. And we'll then have to do the same with this parent build if it's valid. So convert validated, there we go. We want to get the other attach point and say set connected build. And we're going to set the other connected build to the parents right here. There we go. Let's move this a bit closer. There we go. And if this happens, we can return true. If once again it's invalid, we return false. Now in this one we want to leave it pure, but for the can connect conveyor we can make it in can connect conveyor we can put it as pure, but for linked we want to leave it as unpure. So that does it for our blueprint here. We've already done the construct script, correct? Yes. So we can close our attach point. We shouldn't need it anymore. So let's go and do that. So next up, we're going to actually modify very quickly some things in the player, sorry. So for the line trace, we actually want to set up this here so that we can choose which one we want. So trace channel, attach it there. For the line trace channel within the spawn build, we want to change you to general. Just give it a bit of space. For the one inside of moving builds, we want to leave it on visibility, no problem there. Let's just move it to the side. Next we have determine delete, which is going to be the deconstruct one. That's the whole point of the thing here. Just move it all a bit further. And that is all the ones, if I'm correct. So that's all the ones we have here. We're going to have to change some other collisions as we go. But for now, this is all we need to do in the player. So let's go ahead and close that. In the support, we're going to need to change our collisions as well. So let's open that as well. So select the top, the base, and the ISM. And here we have our new things. So we want to make sure we disable the general. So put it in ignore. Leave the other three there, no problem. Go. And next up, well, we're done with our ones there, so we can close that. We want to go into the builds now, and in our parent script we used for IsBuildable, we want to actually make this, because currently we have no way of detecting whether we hit something, so we're going to set that up now. So it's going to be very, very simple. We're going to get actor bounds, and we want to include from child actors, and what we want to do is very simple. We'll get our origin, we'll say box trace by channel, attach it here, and very simply, if we do not hit something, we can place it. Now for the location, we're simply going to put origin to both. Correct? Yep. For the half size, what we'll do is we're actually going to multiply this by 0.9 on all the axes, so that we actually have it slightly inwards, because otherwise we're guaranteed to pretty much hit something every time because we're resting on the ground. We want to put this as general as well. And we can compile and save, and if we try and press, for instance, now this, we shouldn't be able to place it there normally. So it's not changing color, but we can't place it here. But here it works fine. And normally what we're going to be setting up now is that we can actually do this. Because currently right now we actually have 2 supports, which is useless. So we can close our builds here. Don't need it anymore. Let's close that. Next up is the conveyor, where most of this stuff is going to happen. So we're going to go and start off with our new function. So we need one function here, which is going to be called CreateAttachPoint. So for CreateAttachPoint, we're going to need 4. Actually, we're going to need a few more variables than that, but we're going to need some variables here. First one is going to be what we'll call this underscore start AP. So AP for attach point. So we want it to be of type attach point as well. And we're going to need 4 of these. So this is going to be end. So make sure you remember this. And then we're going to have another one, which is other. So start this time as well. And another one, but this time end. Then we get rid of the 0, 1. We also need the directions of our actual spline. So we're going to call start direction here. And it's going to be of type E underscore direction. So our enumerator. The same for the end, obviously. So end direction. And that does it for our variables. So let's start with our create. One thing also, actually, before we do that, we're going to make another macro very quickly. This macro is going to be used just to inverse the directions. So we'll call it inverse direction. And it's pretty simple. We just take in, or just grab it here, it'll be a lot quicker. We want to put an input and output of direction. So we'll call in direction and out direction. And very simply what we do is we do a select, attach it here. If it's an input, it becomes an output. If it's an output, it becomes an input. Non-specified remains the same. Close that. And we can do our CreateAttachPoint. So we want to start off with a sequence. and we'll do the top first. So for the top, what we want to do is we're going to create an actor. So create actor from class, and it's going to be the attach point that we made. So we can split the transform and attach it here. Actually, to be fair, no, we do need to split it here. So we want to start with our spline, and we're going to get location at spline point, and that's going to be 0. Very simply, 0. Make sure we put it as world because this is creating an actor. Next, we want to do the same thing, but with the rotation. So get rotation at spline point. But we need to actually split this because we want to specifically rotate it by 180 degrees on the Z here. So we want to do plus 180 here and make rotation, or make rotator, sorry. Place the Y and the Z and attach it to the rotation. What we'll do then is we will call our this start AP, or this start attach point, and connect it here. Next, we need to make sure that we set up our parent that we just created, as it kind of caused everything to work. So set parent build, and it's going to be self. So align these up and put them there. Next, we can copy these two, and we're going to say attach actor to actor. Make sure that the parent is self, and we can do that there. One thing to do also, make sure we keep it as world, otherwise they'll set themselves to 0. We also don't need to weld simulated bodies, it's not necessary. And finally, what we need is we're going to get our other start here, and we're going to check if it actually exists, because we're going to be setting it up in the update location later. If it does exist, we want to say link connected builds, and we're going to be linking it to this start AP. So no matter the scenario, even if we have connected to something, we still always want to spawn this new one, because that's how the system works. So that does it for the first part of the sequence. So the next one is going to be the endpoint. Oh, actually, let's not forget that, world rotation, sorry. So we can copy this, and I think we can also copy the rotation as well, but we don't want the 180. We just want to connect it directly as is. So we can recombine, attach it to the spawn, and we do need to change this. We want to get last spline point here. So we attach it to both, and this time it's the endpoint. So this end. Same thing as before, we want to do these two, so we just copy paste and just change the actual values here. So right click and change it to this end, and change it to this end. Now here we're actually going to have to update our start directions. So we're going to get a sequence. The first part of the sequence is going to check which ones we already have. So we want to get a reference to our other end here. We want to check if it's validated, so convert here. And if it is, we want to link connected builds. And the other build is this end, obviously. Just do that, there we go. Line them up. Now, if obviously this is where we use the branch here, if it did work, then we can actually set up our local variables here. So we want to get our other end, this one here, get its direction. And because we're talking about the end, given that if the start is input, then the end is output, obviously, because that's how it works. You can't have two identical sides. So we can simply set this to the start direction because it's the other side of the end. And to set up the end, we simply do the inverse macro we made and say set end direction. Go. And next we need to do the condition if this is not true. And so what we need to check is if the start is true. So get other start here and set is valid. What we want to do is get its direction, because if this is true, then there's no other condition, so it has to be true. So we want to set end again. No, sorry, not again. This time we set end because we're talking about the start. so it's identical. Same trick as before, copy the macro, and we want to set start direction. And to finish, if neither of these are true, that means we've just created a conveyor in nowhere, it's not attached to anything, then start is going to be input, and end is going to be output. So there we go, output. So we can compile and save. And one last thing we need to do is, with this information, so with this now, because we've set them up, doing right here. So now we actually need to set these up, sorry. So we've set these ones up. We've set our current, our end and start in the actual conveyor, but we need to set up their attachment. So this start AP is going to be the start, so we're going to set direction, and it's going to be to the start. And we'll do the same thing for the end, which will be its end, or this end, more like. So let's line that up and attach it here. We can apply this to the end of the sequence, and we're done with our attach point. So our attach point needs to be placed in the place build, and it's going to go right at the end. So let's go and open that in our place build. Before this, obviously, we're going to call attach point, create it. And one last thing we want is we want to get a reference to our conveyor belt material and say set scalar parameter value. So this is going to be speed, and with the speed we're going to do a select, and the wildcard will be our start direction. So if we're going forwards, so it's an input, we want 0.2. If it's not, then it's minus 0.2. So later, once we set up, for instance, the speed of the object, once we add that in the next part, we'll probably add a value here instead, which we'll be calling speed. But for now, we'll just leave it at that. Make sure you reattach the return node or it won't work. Next is the update look. Actually, no, before we do that, before I forget, because last time I did forget that, we need to finish here. Because right now we need to tell it if in our last point here, we don't set up correct, we don't do anything here at the start, meaning it won't exactly know what its directions are then. Because if we attach, for instance, a point A at the beginning, we need to assign the point, if we attach the start, we need to know that the end is already defined. It's not because we only authorize non-specified. At the beginning, if we hit something that is, for instance, going output, then it becomes an input, then we can't attach the end to an input because that would be incorrect. We'd have two identical extremities. So we have to set that up here. So in place build, if we actually hit something, so look for our other start here, convert to validated get. So if we do hit something here, we need to tell it that its connected build, we want to set it, is self, obviously. But we also need to tell the, what's it called? We also need to tell, actually no, this isn't necessary because we're going to set that up at the end anyway with our linked builds. We already do that. So we simply need to get its direction, and we need to say set end direction because it's the opposite side. And we want to inverse here and set start direction. And to finish, we can attach this here, and if it doesn't work, we can also attach it here. So compile, and next up is the actual update. So let's update our location here. So currently right now it's rather simple, but it's going to get a bit more complicated now. Let's start with the actual start. So let's move this down a bit because we're going to start off by getting our hit info, our local one, and we're going to call a check. We're going to break it, obviously, because we can't use it otherwise. And we're going to cast to support. Now, the reason we cast into support and not to our actual attach point is because I ran a few tries, but it's much easier, or at least we'll be using a much we'll be using a lot less of the A attach points if we don't have any on the build support. So we just have a different system for the support. If we hit the support, if we hit in front, it'll appear in front. If we hit the back, it will appear in the back, very simply. So we're just using that instead of going out of our way and making an attach point for each support, which might not be which isn't really necessary because the support alone does nothing. It's not connected to anything. It's mainly visual. The game could work without it. So what we want to get here on the support is we want to get attach points. So make sure you get the actual one, and we can get actually world location directly. So get world location here. So we can line those up. And did we create the variable last time? No, so we need to create a transform here. Form, there we go. So of type transform. And we're going to assign that here. And we'll use this transform here. So get actor transform. And we will plug that in here. So the reason we need that is because with our hit here, we're going to check whether we're in front or not. So to do that, we get impact point. We inverse the transform location, and we do it based on L transform. So we can compile that, not compile, hide it. And with this, we want to break it, and we want to simply check if X is superior to 0. If it is, that means we're in front. If not, that means we're behind. Last thing we need to do is we need our rotation. So we want to get actor forward vector here. Actually, I'm not sure. We'll do it my way, but we'll try with the rotation. So we want to get actor rotation. And so for rotation, what we want is we want a selector rotator, and we'll do that there. So the thing is, if we do this, we need to actually remake a rotator here. So it's a bit more annoying to do, but it does work as well. So we'll just do it this way. So we then need to make rotator here, and not the Z. We want the Z and the Y. Attach them all again, and plug this into the B. So then we want to call this and say set actor location and rotation. Because we're talking about the beginning, we can just change its location like we have always done. Next, we need to say start support, and we need to tell it to be hidden. Set actor hidden in game, and as we did in the function, if I remember well, it should be in the place, right? Yeah, in the place build, we made this function. So that's the whole point of this one. As we said, if it's hidden, it'll destroy it at the end. So with update location, we now say it is hidden. And obviously, if we hit something like this, we need to make sure that we say that our other start is cleared, that it doesn't exist. So with that, we've finished the first part. Next, we need to do the actual attach point. So we're going to do cast to attach point, and we'll have to copy this and get another reference like that. There we go. Now, this one is the last one, obviously. If nothing's hit, we do it normally. This one's much easier. We want to can conveyor connect, and we'll get our start direction, which in most scenarios will always be non-directional or non-assigned, non-specified, sorry. So in most cases it will be okay, but unless something's already connected. So next we want to reroute this, not that one, we want a reroute. And put that here, and we're going to set other start on true. On false, we want to make sure that it's unchecked or reassigned to empty. So we want to get actor location, we want to get actor rotation, and we simply want to say set actor location and rotation again, and we'll set it to these two. Go. And once again, we copy this because we need it to be hidden. And to finish, the last one, which is what we've always had, is we'll set this visible again because we need to see it. and update location. And the only thing we need to add at the end is our start and say you're hidden. So let's realign these. And with that, normally, if I'm correct, we can press 1, add a support. And if you press 2 and connect it, it appears in front. And if we do the same at the end, it also appears behind as well. Now, if we do that, we can place it. And normally, we might not be able to see them, but if I display collision, we have our attach points at the end here. You can make them visible if you want for now, that way it's easy to use. But there we go. So currently right now, they're not correct because you haven't given them an offset. So actually, let me just double check, because I think by default in my project, I did give them offsets. Let me just check. Yeah, okay, so by default, let's go back into our attach point here and give them an offset. So we're going to give them an offset of -15, 0, and -20. So what this offset will do is actually, let's make our box visible. So search for hidden in game and uncheck that. So if we now re-put it, we can see it. And the whole point of this is so that if we try and place something here, the box or the attach point is actually around our support. So it will take over kind of what can be hit without us having to reference it or to hide its collision every time we try and attach something. It's simply just over it. But if we try and delete normally, as we said, the deconstruct doesn't apply to the actual trigger volume or box volume from the attach point. So we can just simply do that and it won't cause any issues. Same works here as well and at the end as well. So let's go back to our build conveyor. Now that we've done our start point, we need to do the same pretty much for the end point. We can leave this sequence. Let's just move this down a bit because this is the next bit. So once again, same thing as before, we start off by getting a cast. So actually we'll just copy the beginning, at least some of this. So in my case, I'm mainly getting the different casts because they're annoying to redo. So we'll get our cast. This we can move all the way down to the bottom. We'll attach it at the end. Let's go here, attach that, and here we go. So with our attach point, we have the same trick as before, but let's start with our build support. So we're going to add our transform here. And can we just, no, we can't. Get actor, transform. Same thing as before, same trick. We set our transform to use it. Then we want to get attach point world location. Same trick as before as well. Now I realized something before in our update location, we kept this as separate, but we could have made it into a function because we used it a lot before. So if you want, you can remake it into a function, but here we'll just copy it for the sake of it being easier than going through everything and remaking it. So we'll attach this here because this is what we're going to be setting up. And unlike before, we need to change some of this. So for the attach point, it's going to be world location, pretty simple. Next, what we want is for the vectors. So for the vectors, we actually need to do something similar again. We want to get forward vector of the actor, actor forward vector. And we need to multiply this by -1. So because we need, obviously if we're behind it, we need it to know that. So we'll do another select vector here and connect B to the actual normal one. So let's just add a few reroutes to make it very clear. And attach our boolean to the pick A, and we'll then multiply this by 100. And we can then just simply connect this to our start and end, or in and arrive tangent, sorry. There we go. So obviously, same as before, we do need to set our end support here as hidden in game. Set hidden in game true. Let's attach it there. And we need to say our other AP end is false. Yeah, that one, yeah. Now we can move on to our attach point again. So for our attach point, same trick as before, we want to call can conveyor connect. End direction. And what we want is the branch again, and we'll be attaching a reroute here again to set other end AP on true, and on false we'll be setting it to empty. Did we? Yeah, we set it there as well. Okay, so once again we'll need these two again. So copy these, place them right here, and this time we want to get actor location, and there we go. And for the rotation, what we'll do is we'll get forward vector, and we'll be multiplying it by -100 this time. So make sure you put -100. So there we go. Also, if it's not the case, make sure these are both world. Then again, we want to call this and set it hidden again. And the last bit, copy this, make it visible again, so uncheck the new hidden. Attach it to the cast failed. We can move these a bit closer, and what we want to call is also our other end, set it to false. Or empty, sorry, not false. Go, compile and save, and now we should have everything fully functional. So if we start by just creating a simple spline or a simple conveyor, if we press 2 and connect it, it will automatically connect itself there. If we click, okay, so apparently we can't place it because we're hitting something. So I think it's got to do with the collisions that we changed, so I just need to make sure that I checked everything correctly. So it's likely just an issue with the collisions. So give me a second, I'll just find what that is. Okay, so I just double checked and it's what I thought. Okay, so I believe the issue is in IsBuildable. So in the function IsBuildable of our conveyor belt, we just need to change this from visible to general. Let's go and do that. I just have invisible here, let's just remove that. And normally, if we run this now, we shouldn't have an issue anymore. There we go. Obviously, if it's too short, still the same problem because that's how it's set up. But if we connect the two, as you can see, they all run in the same direction. Let's do another one where we start like this, but we connect it the other way. So if we go and connect it like that, it should all align because it knows that this one is already set up. So it will tell it to move in that direction. So that does it for this part. In the next part is what probably most people are waiting for, is the actual items moving along these conveyors. So that will likely be next week, if all goes well. I'm currently still working on it on the side, so it's not finished yet. But I'm almost there, so it should be ready for next week. I hope you enjoyed, and I will see you in the next part. Goodbye.